Hello, my name is Victor Ardulov. Today I'll be presenting our work on identifying truthful language in child interviews. This is work done in collaboration with my colleague Zane Durante and my advisor Narayanan from the Signal Analysis and Interpretation Lab, as well as Shauna Williams and Professor Thomas Lyon from the Child Forensic Interviewing Lab, all from USC. Child forensic interviewing is administered when a child is suspected to be the victim or witness to a crime. It's a protocol that's followed semi-structuredly in order to elicit testimony from a child. The child is most typically a victim or witness to a crime performed by their guardian or caregiver. As a result, children are often put in a position of conflict. They can be coached or coerced in order to deny wrongdoing. Simultaneously, recalling the trauma induces stress and can lead to a false denial. At the same time, children may misunderstand what a legal professional is saying to them, which can lead to false allegations, leading to profound legal consequences. This is all to create the context that understanding when and how children are being deceitful or not truthful, it's critical to legal proceedings. In the past, previous work has identified that deception in children is often confounded with the developmental nature of their communication ability. This is to say that since children are still learning to speak and communicate with adults, they can often be deceitful or not truthful by accident, give off very obvious cues, or the cues that they do give off are confounded with the general inability to communicate. Previous work has also shown through meta-analysis that adults discern child truthfulness from deception with an accuracy of about 54%. Automated deception detection work has largely focused on adult court testimonies. It's found a number of different modalities, including language as a predictive feature in determining whether or not a jury's verdict will side with the defendant's testimony of innocence. We use this context in order to justify the use of vocabulary and emotional content and language as an input into models in order to discern between truthfulness and deception in children's testimonies. There's a long history of difficulty in determining ground truth from real-life court proceedings. It's often inappropriate and impossible to identify whether or not a child's testimony was truthful in real-life settings. As a result, simulated interviews are experimentally devised in order to have a known ground truth label. Our data set consists of 217 transcribed simulated interviews. Each interview includes one child. No demographic information is known about the child other than the fact that they are of an elementary school age. Specific ages, genders, and any other demographical information is not included in the data set. Each interview is conducted between a child and two adult experimenters. One adult experimenter is known as the confederate, and the other is an interview. It consists of three separate phases or sections. The first phase is known as confederate play. One adult, known as the confederate, plays with the child and some toys. One of the toys may or may not be rigged to break during the play. If a toy break does occur, we call that a transgression, and the confederate asks the child to promise not to tell anyone, including the interviewer, about the toy breaking. At the end of the confederate play, the confederate exits the room. The interviewer then steps in. The interviewer is initially blind. The interviewer is blind to whether or not a transgression occurred, and follows a semi-structured script that is based on the CFI protocol, but which explicitly does not discuss whether or not any of the toys are breaking. We call this process rapport building. The point of rapport building is to instill a sense of comfort in the child with telling narratives about their life. Rapport building largely circles around asking children to tell the interviewer about facts from their life, such as what they like to do at school, who their friends are, or things about their family. Once the interviewer has reached the end of the semi-structured script, they will transition into a phase called recall. During recall, the child is asked to name every toy and narrate what happened to them, including whether or not one of the toys broke. If the child discloses if a child admits to the toy breaking, we call that a disclosure. Most importantly, in order to simulate the stakes of non-coercion required from the interviewer is not allowed to be forceful or repeat any questions unless the child clearly indicates that they did not understand what the interviewer was asking about. In the end, we end up with this distribution of disclosure and transgressions. We can clearly see that most of the children experienced a transgression. And of the children that did experience a transgression, a large majority of them did not disclose. We defer to the disclosure occurrence and transgression occurrence as indicating truth, and non-disclosure in the occurrence of a transgression as deception. We largely leave out the non-transgression and disclosure class as it is small and negligible, but also because it's a clear indication that the child misunderstood the task. We can see from the data distribution that there's a clear class imbalance for the non-disclosure and transgression state. We extract features from the transcripts by converting the transcripts into term frequency inverse document frequency, or TF-IDF, vectors that represent each session as a bag of words. We look at both unigram and bigram models. Psycholinguistic norms are continuously valued ratings for affective perceptions of words. We use the psycholinguistic norms as defined by the Emoto word dictionary created by Malandrakis et al. In order to construct summed values of valence, arousal, and pleasantness, as well as age of acquisitions in the transcripts. We experimentally evaluate two tasks. Task number 1 looks at the classification of deception from truth. In this case, truth looks at both when the child is disclosing in the occurrence of a transgression and not disclosing in the occurrence of a non-transgression. Task 2 looks at only the cases when the child is telling that no disclosure occurs. We simulate adult predictions by bootstrapping 10,000 repeated random simulations. The random simulation has a 54% chance of correctly predicting the label. We use this in order to find the mean and a distribution, and use the 95th percentile as a baseline to represent significant improvement over adult prediction ability. Neural networks, decision trees, and random forests are all included in the analysis as models. We look at data splits across using only child and child interviewer information, as well as unigram and bigram models. We look at different sessions across using rapport building and recall, as well as the inclusion and exclusion of psycholinguistic norms. For task 1, only 12 total models were able to predict whether or not the child was telling the truth with significant improvement over adults. Inherently, we notice that random forests seem to be performing better when only language is being used in this case. However, when psycholinguistic norms are included, we notice that this trend ends. And instead, now decision trees and neural networks are able to outperform random forests. However, largely, there's really no consistency in the results that we observe. No one model outperforms any other model with regular expectations. Looking at task 2, we notice that despite the F1 score baseline being lower, no models are able to outperform the baseline without psycholinguistic norms included. When psycholinguistic norms are included, only 3 models, all decision trees, are able to outperform the baseline. Due to the fact that in task 2, the decision trees were able to perform so well. And in task 1, decision trees for the child-only recall phases were also able to beat the baseline. We use those models as a way to evaluate the inclusion of evaluate the importance of psycholinguistic norms. We do this by looking at the probability predicted by the model for truth, and we correlate it with the value of each psycholinguistic norm. Notably, in human behavior studies, a correlation that is significant, p less than or equal to 0.05, that is close to 0.3, is often referred to as a significant effect size. We note that the two correlated features, psycholinguistic norms, that are closest to this significant effect size are pleasantness and age of acquisition. The reason for this leads us to suspect that as children are lying, they use simpler language reflected by the age of acquisition, but more pleasant language, trying to use a pleasantness or pleasantly perceived words in order to mask their deception. The number of significantly improved models over the baseline between the two different tasks suggests that the language modality is better at classifying disclosure from non-disclosure than truthfulness from non-truthfulness. The results indicate that while children are very effective at deception when it involves concealment, children's vocabulary and more importantly, their affective information provide robust insights into whether or not they're telling the truth. In conclusion, in this study, we evaluated an initial collection of models in order to detect and understand the underlying child deception models, child deception behavior. We demonstrated the effectiveness of these models in a low resource circumstance, and we're still able to outperform adult humans with statistical significance. These studies allowed us to understand more deeply the ways that children might behave during interviews if they are trying to conceal a wrongdoing or a transgression that they had witnessed. In the future, we hope to include interlocutor dynamics over time and across different modalities, including semantic information and their speech signals, in order to better understand the exact dynamics by which children might be deceitful. Thank you for listening, and we'd like to acknowledge all of the participants in our study, as well as those who transcribed and coded the interactions. For any other questions, please feel free to reach out at ardulov@usc.edu. Thank you.